Number 4. Well, we've got another polynomial, don't we? F of x equals x to the 4th. So 4th degree, what about the ends there? The end behavior on it, well, on a 4th degree or even degree, they're both up or both down. And in this case, with what we've got, both up or both down. Well, the A is we got a positive x to the 4th, so that would mean both ends are up. Here. If A was negative, they would both be down. Okay, I don't want to go that far. All right, what about the y-intercept? Same deal, isn't it? Set x to be 0 for the y-intercept. Well, that's nice. That's 0. That's 0. So this is 32 y-intercept. X-intercept. Well, that's a little more involved because here we got to set the y to be 0, f of x to be 0. And so we get 0 equals x to the 4th minus 18x squared plus 32. Well, it's a little more complicated, but we can do this, right? Just set, go about factoring this, right? If I factor x to the 4th minus 18x squared plus 32, that's going to be two parentheses, x to the 4th, do your x squared and x squared. And then with 32 on the end, with minus 18 in the middle, that's 16 and 2, both negative. And so that, we can solve those, set those both equal to 0. Do a little square root method. X squared equals 16, so x would be the square root of 16, but plus or minus, which is plus or minus 4. Here, x squared would be equal to 2, move the 2 over, and so that would be x equals, by the square root method, the square root of 2 plus or minus, which is about approximately 1.4. So it would be plus or minus 4 and plus or minus 1.4 for my x-intercepts. So if I put those down here, negative 4, positive 4, 1.4, and negative 1.4, and then the 32 is my x-intercept. Here's what it looks like before we do some other points. Okay, and again, the other points that I want, the table here, again, are x values between the x-intercept. So let's do negative 3 and let's do positive 3 to get us some points between my x-intercepts. All right, so if x is negative 3, I would have negative 3 to the 4th minus 18 times negative 3 squared plus 32. So that's positive 81 minus 18 times positive 9 plus 32. That's 81 minus 162 plus 32. What does that give you? I see that as negative 49. And if x is positive 3, notice, we get the same thing. Because that will still be positive 81, that will still be positive 9, so we get the same thing in this case. All right. So at negative 3, I'm at negative 49, just almost off the chart there, graph. And at positive 3, I'm also at negative 49. Both ends are up, so here we go. Connect the dots here. Down, back up, get my y-intercept, down, back through my x-intercept, through that point, and then back up. Okay. All right. Those should be a little straighter, but bear with me there. Okay? All right. Question or concern? All right, number 5. Now we have a rational function. Remember on those, what do we look for? We look for asymptotes and intercepts. Vertical asymptote, how do we get that? Set the denominator equal to 0. 3x plus 4 equals 0. That gets me, subtract 4, 3x equals negative 4 divided by 3. So the vertical asymptote's negative 4/3. So we draw, that's negative 1 1/3. So at negative 1 1/3 we draw a dotted vertical line. Vertical asymptote. Horizontal. How do we get the horizontal asymptote? Well, horizontal asymptote, you look at dividing A over B, where those are the leading terms that match up. And so we look at, in this case, 2x divided by 3x, just divide the middle term, leading terms there, and cancel those out. So 2/3 is the horizontal asymptote. So we draw a dotted horizontal line at 2/3. All right. Then let's get a couple of intercepts here. The y-intercept, same deal. Set x to be 0. 2 times 0 is 0, minus 5. 3 times 0 is 0, plus 4. So that's a negative 5/4, which is negative 1.25. The x-intercept, same thing. You set y to be 0, which is f of x to be 0. Which sets up this equation, which looks pretty complicated, but if you multiply both sides by 3x plus 4, the 3x plus 4's cancel out. And so it winds up just being, and 0 times anything is 0, so this side's 0 still, and this side 3x plus 4 is canceled, so we just have 2x minus 5, which if you add 5 and then divide by 2, we get 5/2 is the x-intercept. So 2.5 is the x-intercept. 2.5 is the x-intercept, and negative 1 1/4 is the y-intercept. Right about there. Okay. All right, now on these, as far as table of values, what I wanted was values around the vertical asymptote. And so our vertical asymptote's at negative 1 1/3, so let's get a couple on the left side here, so negative 2 and negative 3, let's say, and then, well, let's also do negative 1 on the other side, since we have a couple of others already. All right, so if x is negative 2, what do we get? We're going back to the function here, 2x minus 5, so if x is negative 2, we get y equals 2 times negative 2 is negative 4 minus 5, and then negative 2, so it'll be negative 6 plus 4, right, on the bottom. It's negative 9 over negative 2, which is 4.5 positive. 4.5 when x is negative 2. Is that okay? When x is negative 3, well, we get this. 2 times negative 3 is negative 6 minus 5. 3 times negative 3 is negative 9 plus 4. So that's a negative 11 over negative 5, which I believe is 2.2. With me? Does that sound okay? What about when x is negative 1? Well, we'd have y equals, x is negative 1, so we have negative 2 minus 5 over negative 3 plus 4, and that's a negative 7 over positive 1, which is negative 7. When x is negative 1, y is negative 7. Yeah, so that'll tell us a lot about what's happening here. At negative 2, I'm at 4.5. Right there. At negative 3, I'm at 2.2. Right there. And at negative 1, I'm at negative 7. Right there. All All right, so like we said, the vertical asymptote divides the graph here into two parts, and we know that the vertical asymptote either heads up or down towards the vertical asymptote. So these 2 points on the left seem to indicate which way are we going towards the vertical asymptote there. Looks like we're headed upwards, doesn't it? On the other side, well, I've got these 3 points, so connect those, so that seems to be a downward trend towards your vertical asymptote, which leaves the ends, and on the ends of a rational function like this, what happens? The graph levels off. At what point does the graph level off? At the horizontal asymptote. So on the ends, the graph levels off at the vertical asymptote. Horizontal asymptote, which in this case we've got marked here. So it's leveling off on the end. So this end goes this way, it levels off at the horizontal asymptote. This end, it levels off at the horizontal asymptote. Okay? Always what will happen on those. All right. Well, on the last page, I've got a couple other review there for you. This is one always asked on this test here. Find the maximum height of an object whose height. So we're back here to the quadratic function. We have a quadratic, and we're not going to graph this one, but if I did, since it's a quadratic, it's a parabola. And which way is it opening? Opens down, right? And so just a real nice little sketch there. Since this is a quadratic, it's a parabola that opens down because of the a being a negative 16. Well, why does that have to do with anything? Well, here's the highest point, isn't it? So the maximum here is at where? It's at the vertex. So this is just another vertex problem. Find the vertex. The vertex on one of these is, well, we find it, h equals negative b over 2a. Find the h that away. So that's negative b is 45, a is negative 16. So it'd be negative 45 divided by 2 times negative 16, which is negative 45 divided by negative 32, which is, let's go ahead and take that to a decimal there. That's about 1.4. And then the k, we'll plug that in for t in this case, so we get k is negative 16 times 1.4 squared plus 45 times 1.4 plus 11. And so that gets me k is plug all that in. I get, somebody check me, 42.64. So the maximum height is 42.64 feet. What is the 1.4? Where does that factor in? It's the number of seconds, right? To reach the maximum height, you need this 1.4 seconds. Okay? All right. Number 7. Find the zeros of the following using synthetic division. Yeah, when we come across a long polynomial like this, we can find the zeros, even though we can't factor it right from the get-go here. We can factor it by using synthetic division. We know that the possible zeros, well, you can make those by, well, basically taking factors of the last, which is 30. So you got, and plus or minus those. So you got, for 30, factors of it would be 1, 2, 3, 5, 6, 15, 30. All the factors of 30, there's a bunch of them. And then even add on top of that, take those and divide them by factors of this front. So, for example, we could have plus or minus a half, divide by factors of 2, the factor of 2 of 2, so forth and so on. I'm not going to list all those out because we'll find them here. All right, so what we do is, synthetic division, we just take, well, let's just start with 1 here and divide synthetically that into our polynomial, 2, -3, -17, and 30. Just do the coefficients there. See if it works. Bring down the 2. 2 times 1 is 2. -3 plus 2 is -1. No. That one doesn't work because what do I need for it to work? I need a 0 remainder. All right, so let's go with 2. Two times 2 is 4. -3 plus 4 is 1. 1 times 2 is 2. -17 plus 2 is -15. -15 times 2 is -30. 0 remainder, okay? So 0 remainder means 2 is a 0 of this polynomial. So there's one of ours. This then gives me 2x squared plus 1x minus 15. Set that equal to 0, and you find the other zeros. And usually you can do that by factoring. You can do synthetic division again if you want. 3 and 5. I think 3 goes there, 5 goes here, and it'll be a minus and a plus 3. I believe that'll give you the right middle term. Set those equal to 0 each. And here we go. 2x add 5, divide by 2. 5 halves. We've seen that one a couple times. And subtract 3. So there's your zeros. 2, 5 halves, -3. Okay? And that is also linked into number 8. Find a polynomial function with zeros of 5, -6, and 0, which has a multiplicity of 2. Well, we can see, obviously, a connection between the zeros and factors, like here. How does it work? If 5 is a 0, what is a factor? X minus 5. Yep. If -6 is a 0, what is a factor? X plus 6. Yeah. Yeah, they work directly the opposite way because of the equal to 0 thing. Yeah, just change the sign and add x there. X minus 5, x plus 6. Now what about 0? Well, if 0 is a 0, then x, just x is a factor. Or x minus 0, but that's just x. And then what about this multiplicity 2? Yeah, that means you want to have 2 factors of it, so it would be x squared added to that. If you have a multiplicity, just add that as a power on your factor. And then I may have you multiply that out. Case B. Okay. All right. Any questions on any of those? I may have you multiply that out. I may just say don't multiply it out. Just follow the directions. Okay. Full it out or. All right. Okay. Well.